The approach we're going to use in this section is called the p-value approach to hypothesis testing. And we talked about the critical value method, but really the one that we want to concentrate on in a practical kind of test that we can use is called a p-value approach. And what it is associated with a probability. Let's get to a couple of reasons why this is actually a good approach and then illustrate what we mean. First of all, a p-value of a hypothesis test is the probability of getting sample data that is at least as inconsistent with the null hypothesis and thus supporting the alternative hypothesis as the sample data actually obtained. We use the letter P to denote p-value, P for probability. So our probability value, or p-value, is going to tell us something about the strength and how far away we are from the actual mean based on our sample data. So the decision criteria here is that if the p-value is less than or equal to a specified significance level, we're going to reject that null hypothesis. Otherwise, we're not going to have enough evidence to reject the null hypothesis, so we don't reject it. In other words, if that p-value is less than our alpha, our level of significance, we have enough evidence to reject. And how far less than alpha it is, that also indicates something about the strength. Otherwise, we're not going to reject that null hypothesis. Okay. So the p-value of a hypothesis test equals the smallest, we say that equals the smallest significance level at which the null hypothesis can be rejected. That is, it's the smallest significance level for which the observed sample data results in our rejection of the null hypothesis. So if we go back now to our normal curve and we take a look at what this means, if we have our rejection region, all right, and we're going to use the two-tailed test right here, so we have a rejection region right here. The p-value that we're referring to is the value of the probability from our test. So the p-value is going to be illustrated as a probability that falls within this range in red or not. Right? So we have a z-value, or z alpha over 2 in our two-tailed test right here, and so we're going to reject the null hypothesis if we're in this region. So what we're going to look for is whether or not how test the significance level at which the observed value test the smallest significance level at which the null hypothesis can be rejected. And the smallest significance level for which the observed sample data results in our rejection, we're looking for what is the smallest value, what is the actual p-value, the probability that we get. And to do this, we're going to be using a program in Excel that I've written rather than having to go through a large number of calculations, so that should make it easier. What we're interested in is the interpretation of the results of our test. All right, so if we're going to determine the p-value of the hypothesis test, we're going to assume that the null hypothesis is true, and then we're computing the probability of observing the value of the test statistic as extreme as or more extreme than the observed value. By extreme, we mean far from what we would expect to observe if that null hypothesis were true. Okay? So if we look at the way that we're dealing with this, our p-value, if we are going to reject the null hypothesis, in a two-tailed range will fall either much higher or much lower than our confidence level interval. If it's a left tail or right tail test, it'll either be much farther to the left if it's a left tail or much farther to the right. So we're looking for that. Rather than the z-value, we're interested in the probability value that we get. And does that probability fall something less than our alpha level required for one of these three conditions? Now, let's say we're interested real quickly here in just asking the question, what are the two reasons why the p-value is prudent to use when you're reporting the results of your hypothesis test? Well, let's look at one reason at least. One reason is that the p-value is associated with the smallest probability of the null hypothesis that can be rejected. So it allows you to assess the significance level at any desired level that we want. In other words, when we're dealing with a critical value, we have one set z-value, and we're just looking in the critical value approach whether or not the z-value that we get from our test is less than a set z-value. But there's no ability to test that strength or set that level to any other thing that we want. In this case, that p-value can be set at any desired level. And what's more is that the smaller the p-value, the stronger the evidence against the null hypothesis in favor of the alternative hypothesis. Thus, it allows you to assess the strength of the evidence against that null hypothesis. So let's go ahead and make that clear right here on this. So we're looking for that evidence against that null hypothesis right here. All right, so if we think about what that means right here, if we were using the test statistic, let's say that we got a z-value of negative 1.19. We're looking to not determine whether or not that z-value is going to make any difference to us, whether or not it compares to a critical value, but we're interested in the probability. What is the probability under the curve, and how does that compare to our alpha level? So what we might do right here in this situation is, if we have our z-value, we can go to our probability table, our z-value table, right, the normal probability table 1, and find what the probability of the p-value is associated with our test. Okay, so here's our approach. We're going to state the null and alternative hypothesis. If we're going to test it, we want to know what are we testing, right? So state that null, state that alternative hypothesis. Second, we want to decide on our significance level. Typically in a textbook, we're going to tell you what significance level to test at, but if you're doing this in a field as an actual statistician, you have to decide, well, what significance level will we accept as a probability to say that that's true? Do we want a stronger evidence? Do we not care so much about that evidence? And then we need to compute the value of our test statistic. I have the program that I've written for you. We're going to use that in this section. And we're going to determine the p-value based on that computation. And then we're going to test whether we should reject or not reject. So if the p-value is less than alpha, we're going to reject that null hypothesis. Otherwise, we don't have enough evidence to reject. And then we'll try and interpret the results of that hypothesis test. All right. There are a couple of things that we can say right away about a p-value. And let's say that we're interested in a 90% confidence level. That is, we will have a 10%. We could say, well, okay, if the p-value is greater than 0.1, that's our 10% probability, then really we have very weak or no evidence to reject the null hypothesis. On the other hand, if p is less than that 0.1, but greater than 5%, well, we might have moderate. It depends on how we set our test, right? If we have a 95% confidence interval, we still don't quite have enough evidence, although we might have some moderate evidence. But if that probability value is less than 0.05, typically we say that's strong evidence. And if it's less than 0.01, that's very strong evidence, right? And so, for example, right here, let's say that we tested a p-value of 0.06. Do we have enough evidence to reject reject that null hypothesis? So let's see. If alpha is 0.05, what does that mean? Well, we might have some moderate evidence right here because our p-value for our hypothesis is 0.06. But really, the p-value, let me write this out here, right? We're looking to see if the p-value is less than or equal to the alpha level, right? So in this case, we ask the question, is that true? Well, no, 0.06, so we do not really have enough evidence. Not enough evidence, right? So we cannot reject the null hypothesis, right? So we fail to reject. How about the alpha level 0.01? Well, in this case, yeah, applying the same test, our p-value 0.06 is definitely less than alpha, and we have some moderately strong evidence, at least in this case, to reject that null hypothesis. Finally, what about with this? What if we said the alpha level itself was 0.06? Do we have enough evidence to reject? Well, based on what we said before, we said that we're going to reject if p is less than or equal to alpha. So we're kind of on the cusp right here. we might have some very small level. Well, it's actually equal to. And in this case, well, do we reject? We might have enough evidence to reject. This might indicate actually that we need to do our test again. All right, more to come.